Yeah, okay. So that's there. If you miss a class, um, everything that I say hopefully will end up on YouTube and everything that's on the screen as well. Okay, second thing I want to ask you about is Edroller. Who has logged into Edroller and found this subject? Okay, so most of you have not. Do you know how to get in? Okay, please speak to me or Felicity Smith in the library if you need help getting into Edroller. You need to get into Edroller before your school holidays because if for whatever reason you want to learn the course and work on some of the stuff I said as holiday homework, I won't be giving a class on that content, but you could watch a video tutorial on Edroller before you attempt the questions. So it's important that you know that you can get in before you finish up tomorrow. Okay, so I'll ask again tomorrow, and if you're not in tomorrow, we'll get you in. Okay, next thing. So on the weekend, I took up a little programming project, and I want to show you something. So I've taken the liberty of combining all the VCA exams into one file and one booklet with page numbers. So this is 2006 to 2015. Why haven't I given you 2016 and onwards? Those exams we're going to save for the end of the year, okay? So um, when we finish term 3, you're going to do about 12 sets of past papers to get ready for the exam. But don't touch those yet. What I want you to do is if you want to look ahead or get ready for a SAC, use these exam questions. Now, because I've already put together the exam questions for you, you don't need to buy checkpoints now. Okay, because checkpoints just categorizes past exam questions by topic. I've already done this for you. Okay? All right, so that's on Teams as well for you to pursue in your own time under the VCA exams folder. And this is really laggy. Class materials, VCA exams, and the first folder, compiled by topic, okay? If you want to print out, just let me know. And printing is free for me, so I can just give it to you for free. All right, and last one is class party. So I owe my Unit 1-2 class a party. We only have a class tomorrow. I think it's period 4 tomorrow, so maybe some light snacks, unless you want to eat your lunch tomorrow. No, the, you can. You do it. I said you can do it, and I can sit here and watch the drama unfold. No, 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 no. So we have to cover content tomorrow, but I will let you eat while I'm talking, okay? Tomorrow, Thursday. Now, year 12s, um, we need to organize food for tomorrow. So maybe I can bring drinks, just because I think that's easiest for me. And we just need a few people to bring some food. So is anyone happy to bring some chips or something tomorrow? Thanks, Brian. So Claire and Brian? Yeah. Year 12s listening. Claire's got a question. Yeah, so maybe we can organize the details at the end of the class. How about that? Okay. So we got Claire and Brian are happy to bring stuff. I'm happy to bring something, and maybe one or two more people bring something tomorrow. That would be swell. Okay. But we'll talk about that maybe at the end of the class. But let's get into some maths. And just to be really clear, as far as I'm concerned, if you weren't in our class this year, you are still invited to the party and you are entitled to partake of the food tomorrow as well. Sorry? Not telling. Okay, I'll give you a hint, Cooper. When I came for a week last year, my birthday happened in that week. Figure it out.
Yeah, so that was started of December, so you're really within the first like 10 days. Well, it would have to be in the first 10 days because the week after was the week for my birthday.
All right, year 12s, listening up. You need your CAS calculator. If you don't have a CAS calculator, I believe there's one in the office there. Told you to be prepared for class. All right, so please go to the main menu.
I'm at the main menu.
Click on New Document,
Ooh, I like this.
and you want Lists and Spreadsheet.
Got it. Wait, is this going on YouTube too?
Yeah, it's recorded. Yeah.
Are we doing it for the public?
Yes, so please go to List and Spreadsheet. Now, I'm just going to make up some data. So please put this data into the A column. So I just need to make sure this works.
Do we need to name the A column?
Yes, please give it a name. Just call it scores or something. Okay, I've just made up some numbers. So please type these numbers into the spreadsheet in the first column.
What's the other one?
There's only one variable at the moment.
There's only one variable.
Yeah. All right. On your CAS calculator, please do it on your CAS, Brian. Yeah. Okay. All right. So in the very, very first row where the letters are, put your cursor over that and you can actually type in a name. So let's just call it scores. So I'll just quickly come around and make sure you're all on track. Yes. You got
You have a class presentation. I mean, during the exam, I was actually paying attention.
Okay. So if you weren't with us in year 11 this year, this is a very, very common thing that we do in term 1. You're given some data and you need to type it into the CAS calculator and then you'll generate some statistics or some graphs. So today, we're going to generate the graph. So how do you do it? The keyboard shortcut is Control-I. So please take a moment to press that now. And I'll write this down as well. Correct. Select Data and Statistics. This will open a new window.
And it should look something like that.
Okay, so at the moment, if you followed all the steps, you will have a bunch of dots floating around in space. Not very useful. So what you want to do is hover your mouse. So click to add variable, but only on the x-axis. Okay? And that's why we gave the variable a name. If you didn't give the variable a name, it'll be very hard to find it there. Okay, so I've got a dot plot. Is that what you've got as well?
Yeah.
Okay. All right, so we have a dot plot now. Now to change it, click on menu, plot type. Yeah, do a histogram. And you see a nice bar chart now. Okay. Yep. And guys, can you also get a box plot together as well? So menu, plot type, and box plots. So just make sure that you can get all three plots. All right, so I'll just quickly check. Everyone's got it?
Oh, Brian, what are you doing? That is so wrong. Yeah, I know.
I got all four.
Oh, no, it's not. Oh, with this, because this has the bond, would that not be used as as like the black book for year 12? Okay, I just wasn't sure because I don't want to like write a whole year worth of stuff and then get in trouble for it. I mean, worst case is I could always just cut it out. So what you're telling me is like, I should go grab Mr. Ronald, all drops.
Mr. Sure.
Can I get a colour? Look, I need to
Yeah.
get back. Go on.
Yes.
There's always something. So if I just go into there, off a bit of that.
Okay, year 12's listening.
Okay, so I'm gonna go home and grab the box.
All right, let's have a brief chat. So in the data that I gave you just now, by the way, if you want to go back to the spreadsheet, use your mouse and click on the tab 1.1, which is what I've got.
Or I just keep that on yeah, I might do that. So this one is now.
All right, so let's refresh what we talked about last lesson. I just made up this data. Let's pretend these are scores on a test, and there are no half marks given, so you can only get whole numbers of marks. What kind of data would this be?
Raw data.
There were 4 different types we talked about last lesson.
It's numerical.
Nominal.
Nominal belongs in categorical data. This is numerical. Why is it discrete?
Because it's whole numbers.
Yep. So I just said you can't have half marks, so only very specific numbers are possible. So that's why it's discrete. Okay? Now, last lesson, we looked at ways of summarizing and representing categorical data. So that was a frequency table and a bar chart. Today, we are looking at numerical data. You'll notice we have a few more pictures available to us. Now, there's one more I want to tell you about. It's called the stem plot or the stem and leaf plot. So, I think I'll just give it to you for the interest of time.
Brian, would you have a small marker?
Okay, what should I put on the right to complete this stem and leaf plot representation of this data?
And
Yeah.
another 5. And then a 3, and an 8, and a 9, and then a 3, and then a 4, and then a 5.
Yeah, I missed a row. My bad. Okay. Thank you. Okay, so I'm guessing you've seen this since year 7? Depends on your maths teacher. Okay. All right. So as old and basic as this is, VCA expects you to know all of these pictures. They could give you a stem plot, and they could ask you for things like the mean, median, mode. I'll talk about that soon. They could ask for a histogram. They could ask for a box plot. They could ask for a dot plot. They could also give you the graph and ask you to interpret it. So you need to be familiar with all of these. Um, and there's one more picture that we need as well. And this is when we have continuous numerical data. So let's imagine I have something like this. Let's say I measured the heights of some teenagers.
So why are they all really short?
Because they're young teenagers. They're not as old as you, okay?
Okay, so have you seen how tall some years
I have.
Some are really tall and then others are just really small. There's no middle ground.
Okay, relax, guys.
They're all outliers.
Shh. Okay. What would happen if I tried to create a dot plot with this data?
It would look really dodgy. There'd be like point. It would be not positive. You couldn't make a dot plot that would not be positive. I mean, you could, but it wouldn't work as well as if you were using just discrete data.
Yeah, so it would be very hard to have every single, like, I don't know how you do this, because you have one dot here, then you have one dot here. Yeah, I don't know. Somehow I'm not convinced by this, that you want to put a picture together like this. So don't do that. Instead, what we will create is what's called a grouped frequency table. Now, it's just like the frequency table that we had last lesson. Let's do it this way. Sorry. I need to be very careful that I don't screw this up. Okay, what would the frequencies be in this table? So I've created the groups for you.
Well, the frequency would just be the amount of numbers between the two points.
Yeah, so the number in each group. So how many are going to be in the first group?
Yeah.
Two. Which ones?
155.
Yeah, so one strategy I saw as I walked around last lesson was when you use your data, you tick it off so you don't use it again. All right, so there are two in the first group. Second group, I think it's these two. Third group, I think there's three this time. And then the fourth group, there's one. Okay, is that all right? All right, so you probably did this earlier in your school days. And if I plotted this, what would I get? What would be the name of this chart? Hints, you've already seen it. Histogram's correct. Okay, so it's like a bar chart, but for numerical data. So 1 for the first group, 2 for the second group. No, other way around. Sorry. Pay no attention to the man behind the curtain. 2. Okay. So I expect you to be able to create this picture as well. Now, if you put this data into your CAS calculator, you might find it doesn't give you this histogram. I'm not going to go through it now, but see textbook for instructions on how to change. They're actually called the bins of the histogram. So each interval, such as 155 to 170 to 1, no, sorry, each group, 155 to 157.9, for example, that's a bin. You can also change what's called the bin width. Now, if I require this on the SAC at the end of term 1, I will tell you. But we didn't make people do that last year. Okay, so I'll be very clear on whether you need to do that. All right, so numerical data. We've got different ways to represent this. So we've got a group frequency table, dot plot, stem and leaf plot, histogram, and box plot. At this point, we just need to be able to make them on a CAS calculator, make them from raw data, and get some raw counts. Are we okay with this? All right. All right. In that case, we're nearly done. So what else? All right, I'll just briefly talk about shape. So if you were in my year 11 class, you've met these words before. When we're dealing with numerical data in one variable, it's often worth asking, what kind of shape does it have? It's not skewly. Positively skewed. So it's one thing to have the data, it's one thing to have the numbers in front of you, but you need to go one step further. You need to be able to tell the story. What is the data actually telling you? And the first element that we're going to look at today is called the shape of the distribution, or the shape of the data set. Now, it's very common to get these two the wrong way round. So I'm going to try to explain it, but we will see what happens. Okay, so I'm going to draw a histogram. Just pardon the fact that it's a bit messy. Symmetric. What? Just as a brief reminder, what does symmetric mean? Yeah, you got like a mirror image going on. Okay. So symmetric is the easiest one. Okay, and if you were to draw a box plot, we haven't done box plots in detail. That's later. That's your holiday homework. I'm still going to draw the picture because it is important. Your box plot will look something like this. Okay, it's going to look nice and symmetric. Now, personally, I actually find this easier with a box plot. So I'm going to draw a negatively skewed box plot first. Now, we haven't covered box plots, but what can you tell me about that second box plot on the right there? Great. So there is a bigger spread of data in the negative direction or lower values. Now, where things kind of go wrong for students. Take a look at the histogram. It looks like the pig is in the positive direction, doesn't it? Right? The higher values. But if you look in the negative direction, there's actually a larger spread. So that's where the larger spread is. So even though what's called the frequency or the density is higher in the positive direction, when you're talking about skew, you're looking for spread rather than frequency. Okay? So even though the frequencies are higher in the positive direction, the reason why this is negatively skewed is because the spread of the data is larger in the lower regions. So when we talk about box plots, 25% of the data is in the middle. So there's 25% here, 25% here. I'm going to rub this off. Can you see that 50% of the data has a much larger spread here in this box plot? Okay, so that's why we call that negatively skewed. Did you talk about skew in year 9 and 10? You did. Okay. So I reckon in my year 11 class, half the class got this wrong when they did the exam in unit 1. So probably something I will put on the stack at the end of next term. We'll expect you to get the skew right when looking at a histogram or a box plot. All right, that's actually all I wanted to cover today. I'll just quickly check if there's anything else. looks like that's everything. There might be some small details that are in the textbook. So as you can probably imagine, I can't cover absolutely everything in the textbook during class. Like I would be talking forever and you get no work done. So I'm making the choice to talk about maybe 70 or 80% of the stuff, and the rest you've got to do in your own time, okay? But I'm trying to emphasize the big picture and the concepts. So what do we do today? Numerical data with one variable. How do we summarize it? How do we visualize it? And how do we describe the shape? That's what we've done today. All right, so why don't you get cracking on 1C and 1D? If you haven't done A and B, I suggest you do that first or leave some space. All right, so you've got about an hour.